Hi, this video is about the difference between mass and weight. Now, in everyday English, mass and weight basically mean the same thing. But in physics, mass and weight have specific meanings. And here those meanings are now. Mass refers to an object's resistance to change its state of motion. It doesn't want to change if it's got a lot of mass. Mass is the total amount of matter making up an object. We measure mass in kilograms. Weight, on the other hand, refers to the strength of the downward gravitational force acting on an object. And we measure weight in pounds or newtons. Now, a good way to think about the difference between mass and weight is here. Mass makes it hard to change an object's motion. Essentially, to stop an object if it's moving, or to get an object moving if it's stopped. Mass makes it hard to change an object's motion. Weight, on the other hand, only makes it hard to lift an object up. So, for an example, I have a 20-pound dumbbell here, and this dumbbell has a lot of mass and weight. It has both mass and weight. Mass is what makes it hard to change its motion. So right now, it's not moving. So to change the motion of this dumbbell, I need to move it. I need to apply a force and get it moving. And its mass makes it kind of hard to do that. So if I want to get it moving back and forth, the mass is what I'm fighting against. It's tough to get it pushed back and forth because it's hard to change its motion. Weight, on the other hand, is only how hard it is to lift it up against Earth's gravity. So weight is the downward force, and so to push against the weight, you have to lift it up. When you lift something up, you're kind of pushing against its mass and weight because weight is pulling it down, and it always has mass as you push it up. So weight is what makes it difficult to lift something up against Earth's gravity. I mean, it's not difficult for me, obviously, but for most people, it would be very difficult to, yeah, you get it. Now, as a final way to try to illustrate this point, take a look at this here. So mass doesn't change, right? An object's mass is a property of the object that does not change based on location, right? Weight depends on the mass. So if you have a lot of mass, you also have a lot of weight, but it also depends on where it's located in the universe. So I have the same person here in 3 different places in the universe. The person on Earth has a mass of 75 kilograms, which if you type into Google 75 kilograms in pounds, that's 165 pounds on Earth. But that's not 165 pounds on the moon. On the moon, the mass is still 75 kilograms, but the weight is only 27 pounds. You're pretty light on the moon because the moon has a weaker gravitational pull. It's not as big as the Earth, doesn't have as much mass as the Earth, and so it has a weaker gravitational force. And therefore, you have less weight on the moon. You don't have less mass, you have less weight. Finally, if you're just floating in the middle of outer space, you still have a mass of 75 kilograms, but you have no weight at all. So your weight is literally 0, but that doesn't mean your mass is 0. You still have mass. So as another example, returning to the dumbbell, imagine the dumbbell floating in outer space, right? It's just floating there, okay? If you wanted to lift the dumbbell, it's weightless, so it would be no problem to lift the dumbbell. But it's still difficult to move the dumbbell, if you know what I mean. Imagine just you as an astronaut floating in outer space in your spacesuit, and you're holding onto this dumbbell, right? If you were asked to shake the dumbbell back and forth, it would still be kind of difficult. There would be some resistance. And that's because the dumbbell, even though it doesn't have any weight, it does have mass. It's still difficult to change its motion. So it's hard to, get it moving or to move it back and forth because it still has mass even in outer space. Well, that's all I have for you in this video. And remember, how you do anything is how you do everything.